So we want to talk about organic molecules. And as you know, organic molecules contain carbons. So you've often seen them in the texts written this way with carbons. Like so. Okay. And as you can see, we have 1, 2, 3, 4, 5, 6, 7 carbons. You will recognize that there are single bonds between carbons, double bonds between carbons, single bonds between carbons and other atoms. So what we're going to do is represent this with a line bond structure. So we've got 7 carbons. We want to go 1, 2, 3, 4, 5, 6, 7. Now we know they're zigzagging fashion. You're going to say, why are they all zigzag? Remember, a line is a bond, and a bond represents electrons. And we know from our basic general chemistry that these electrons repel each other. And so hence we get this zigzag pattern so that they are as far away from each other as possible, and we don't see as much repulsion. We also see that each line represents a single bond between carbons. We also note that there's a carbon at the end of every line. If you're not convinced of that, we'll count 1, 2, 3, 4, 5, 6, and 7. And at carbon 6, we have a bromo, check. And at carbon 5, we have an OH. And we'll discuss what an OH and a Br are in a little later lecture. So don't worry about it. So there we have our groups attached and our bonds. Now you'll notice that because these two lines come together in an upwards fashion, the group is added on the top, and here the two lines of the carbons come down to, and so the group is added on the bottom. That's to make sure that the bonds are as far away from each other as possible. We have an orientation, because hopefully you should know that this is an sp3 center, that the bond angle is 109.5 degrees, and that this is tetrahedral. And so with that, we need to represent that in our diagram, because that is some of our basic knowledge. We need to represent it that way. And then if we go back further, we see between 3 and 4, we have a double bond. So guess what? If it's a double bond, we have 2 lines. So then the obvious question is, if we have 3 lines, you're going to tell me, hey, that's a triple bond. That's correct. And then I'm going to ask you, how many carbons? Can you count? 1, 2, 3, 4, 5, 6, and 7. Okay. So that's how we look at our organic chemistry. That's how you see these zigzags. So whenever you see a zig and a zag, like so, I'll just draw that out. I'm going to put a Br there. I'm going to put a Cl down here, and I'm going to put a OH here. And we'll, as I say, I'll express all of these a little later. You can see that each line represents a carbon. So if we count this up, we've got 1, 2, 3, 4, 5 carbons. Chemical formula. Then we have 1 Br, 1 Cl, and 1 oxygen. And then we know from our basic chemistry, our general chemistry, carbon has 4 bonds. So presumably, I'll use a different color here. 1, 2, 3 hydrogens here, 1 hydrogen here, no hydrogens here, 2 hydrogens here, and 1, 2, 3 hydrogens. So we've got 3, 4, 5, 6, 7, 8, 9 hydrogens. And so when we write our organic formula, we've got carbons and hydrogens, and then everything else is in alphabetical order. And that's how we represent. So when you look at something, you hopefully see these lines are carbons. So if I draw something like this, you go, ah, there's a double bond. If I draw something like this, you recognize it's a triple bond. Okay? And just to point out, if it's a double bond, this is an sp2 center. The angle here is 120 degrees, and this is trigonal planar. Okay, planar. And then over here we have what is called an sp center, which has an angle of 180 degrees. Hopefully that's 180. You get your protractor out. I bet you can measure that on your screen. Pretty close, I'll bet. And this is a linear bond. So that's what we have there. So if we know that, we need to think about the fact that if this is an sp2 center, when we add substituents, we're going to add them at this position and this position, because that will then lead to something that looks like this with our x and our y. And guess what? If you look closely, that looks like 120 degrees. Wow, pretty cool stuff. So there we have some bonding of organic chemistry. I'll continue in the next lecture. Thank you.